Hello folks, part 9. If you're still here, awesome, you're great, keep it up, you're learning, and we're having a bunch of fun. At least I am. I like this kind of stuff, right? So as a promise, in this video, we are going to follow the code step by step and see what happens. So you see already, I have a breakpoint here. I actually have one here. One thing I want to do before we start the debugger is I want to actually have, where is it, sorry, these values in a variable so we can watch it, we can see the value, right? So double pointer pose, which then for pointer is equal to pose 0.x. Awesome. Then we do p norm, normals. There we go. Sorry, it's a float. Here we go. So we can actually see those values. So we put a breakpoint here. Let's compile. Here we go. So I'm gonna press F5. That's gonna kick Maya. Give it time. It's loading. Here we go. So what I did is I trigger a script that load the plugins, load the test scene. So it loads the plane with the deformer. So the plane evaluates, and boom, right? We got our breakpoint here. So we have, I don't want to say that, we have several windows super useful in Visual Studio for debugging, right? One is open here on the left, is the memory. It actually lets you see the same Excel value of the memory. So right now it's all with a question mark because 0000 is basically a value in memory. So we don't have access in our process to this memory. So it doesn't let us see that, right? For security reasons. Then we can also read the disassembly, right? So this function call to what boils down, right? That here there is actual, is that our code? No. Where is it? Here's when we're getting called, right? So this is our function is getting called. Then we have the call stack, right? So you can see where we are. So open Maya, it calls our push deformer. Then we have auto, so it shows some variables. It try to be smart to what variable to show. Then we have watch. Here we can type variable we want to see. Next one, really important, we are going to need is registers. Here we go. So it's going to show us a bunch, all the values in all the registers. So you see here we have RAX, RCX, blah, blah, blah. Right? So that's super useful. We are going to use that. So let me shrink the memory a little. Actually, we don't need to see that much code because here we just have the comments. So if you don't see YMM, just do right click AVX double, right? So it lets you see the content of the AVX register as doubles. So if you remember, the YMM is 256 bits long. So it means you can stack inside there 4 doubles. And that's why we see YMM 0, D0, so the first double, D1, the second double, D2, the third double, D3, the fourth double. All right, and that's repeats for all the others. RCX, you just 64 bits, so you just see one value, and so on, right? So first things I want to see is I want to see our data. All right, so I want to see pose. Where is it? There we go. So that's our first position value. And we can actually write there pose, and here we have our memory, right? We can see this value in all different ways. So you see, now we said, okay, show me the memory as 64-bit floating point, right? So, or you can see no data, or you can watch it how you want, 1 byte, 2 byte, 8 bytes. So that's the same floating point, right? By notation. So it's not easy to read. If it was an integer, it's easier to read the hexadecimal notation, but it's really not easy to read a double because you have the mantissa, you have the exponent, and so on. So it's really not easy. So we can show the memory here directly. So these are our values, right? And it's interesting to note that the y are all the same, right? And it makes a lot of sense, right? Because sorry, the y is probably this one. Is the one I remember. This is probably the w. So let's see. This is the first value. So x, y, z, and w is 1. Okay. So this is the y value, right? And you see, those are the addresses, right? So 40, then 48, because we shift, you guessed it, by one double. So the address is at 8 higher, right? So when we shift from x to y, the value of RCX, you actually expect it to be this, and that's exactly what we're going to get. We will see that in the register. All right? So now we have the value. We also want to see the P norm. Here we go. So we can go see P norm as well, right? P norm. This is our normals, but I think people's might be more interesting. So our breakpoint right now, where is it? Is here. So I want to jump inside this function, and boom, here we are. First instruction. So let's check RCX. So RCX should hold the value of our pointer to our point, right? So it should be this value, right? Is it? Oh, look, it's exactly that. 507040, 5070 is exactly that. So in RCX, we have this memory address. Good, that's exactly what we want. And we want to load that inside XMM6. So where is YMM6? 6666, this one. So we should see the value loaded in the first one here. So I'm going to step to the next instruction pressing F10. Boom! And you see it loaded the value in there. So it loaded the first value, the value we are pointing to, right? So point is minus 12, 5, blah, blah, blah. So here is 1.26, blah, blah, blah. And you see the exponent is plus 1, so it's actually minus 12. Correct. So we loaded the data correctly. Awesome. So next, we are going to load XMM7. It won't display correctly because we asked to show doubles, right? But it's fine. So we are loading XMM7. All good. Now we are converting that. All good. Actually, we can probably switch that to AVX float. Oh, all right. So let's see if we can find. So that's 6F0. This one. This should be our normal, right? So then we are going to convert that to double. So now that should be a double. So we can go back to 6. All right. So here we got. No, 7. Sorry, 7. There we go. So that's our normal, and you guessed it, is 0. Why 0? Well, because most likely it's flat. And actually, it's flat because it's a flat plane, right? So the x component of that normal is 0. So next iteration, we should see 1. In the y component, we should see 1 here. Cool. Now we are going to multiply, right, for XMM2. What's the value in XMM2? Actually, so YMM2, 0, actually 0. So we are multiplying 0. At this iteration, the value is 0. So it's not complete. No, it's not really interesting because we don't have any amount, right? But so probably what I will do, we will let the debugger run, and then I will change the amount like to 0.5 or something we can see, right? But let's actually step by step and see what's going on here. So now we're going to multiply the two values. So it's not going to show anything here because nothing changed. Then we are going to add, and the value is the same because we're adding 0, and then we are writing to memory, and nothing changed, right? Because it's multiplied to 0. Now, that's when we shift RCX. So let's keep an eye on RCX. We expect to see 4, 8, right? Because we are adding 8. So let's see. Boom. RCX incremented by 8. So now we are pointing here in memory. So the next value, minus 2.8, blah, blah, 8 to the minus 15, right? So this mean is freaking small. This is 0, right? Same for RDX. So let's check RDX should increment by 4. Let's see if that happened. Boom. Incremented by 4. That's exactly what we want, right? This is gone. This is gone. Boom, boom, boom. So then we ship RCX by 16. And you see it changed, right? So this is base 16. So the second value changed. The second value of number. Now, R9, right? I don't remember how many points we have actually. But we should be able to see that by R9. I have no idea what that value is. In decimal is 1 plus, is that 13? Something like that. Plus 13 to the second to the third plus 9 to the fourth. Something like that. I don't remember that now. We can probably see, actually, we can probably convert that. I will convert that later. But that should be decrement by 1. Let's see if that happened. So decrement, boom, decremented by 1. Now, I want to see the flags, right? So we see we have several flags. I don't remember all the name of that, but we are actually interested in the 0 flag, ZR. If that gets set to 1, it means we are not going to jump, right? So let's run the compare. We see the 0 flag has not been set. So we are jumping if this value is not 0. So this gets set to 1 if it's 0, right? Because it's 0 flag. So actually, we are going to jump, and we're going to jump main loop. So we're going to jump here, right? So let's actually press that. Boom. You actually saw that, right? We jumped that. Awesome. So we can remove this. And let's set the point to here, to the return. So we press F5. The function run, it computed everything. So R9, you see, has been set to 0. The 0 flag has been set to 1, right? So we didn't jump. We went to the next instruction, which is return, right? So if now we run, oh, there is another breakpoint here. Let it run. And here we go. We are back in Maya, right? So we computed the deformer. We didn't do anything fancy because the value is 0. So we changed that. Sorry. So we changed that to 0.5. The moment I press enter, the node is going to evaluate. The debugger is going to trigger. Boom. Exactly as mentioned, right? So let's jump back in to P-pose. So let's jump. We are here. So I want to see P-pose. Ooh, sorry. So I need to actually stop here because otherwise it doesn't show. Let me show the value P-pose. So what I'm going to do, I'm going to let it run. We are going back into Maya. Let's set that to 55. So we are back here. So I'm going to write P-pose now here. There we go. So we are seeing our memory also. Let's jump inside our function. So F11. And here we go. So let's watch the registers. So that's going to happen the same thing we expected. So we are loading the values into XS and S7 register, right? So we multiply. So the value should be in XMM7. Why is still 0? So let's check XMM2. So XMM20. All right, so that's our weight. That's exactly what we wanted, right? Because it's 5.5 raised to the 8 to the minus 1. So basically divided by 10. So 0.55. Awesome. So now we're going to add our scale value. I would like to see our scale value actually still 0 is correct because the x has no value, right? So we didn't modify the x component, but we are actually going to do that. We should do that for the y component, right? Because the y component of the normal is not 0. So we see we move the value into YMM7. We converted that. Look at that, 1.0. So now that's a double. And since the normal is straight up, the normal is like that, 0, 1, 0. Oh, come on, 0, 1, 0. So now we're processing the y, so it's correct. We grab 1, all right? So next, we're going to multiply XMM2, that we know it's here, so 0.55, by 1. So we should get 0.55. So we multiply that. No, I didn't change the source. Oh, sorry, I actually did. But yeah, nothing happens. It's all good. So we see that now mm7, so xmm7, as the value 0.55, the result of our multiplication. Awesome. Now we are going to sum those two together, and we should see this bad guy here change, right? So we are summing 0 to 0.55, so we're going to get 0.55. And that's exactly what we got, with a slight more precision. Welcome to floating point precision. Now, this the awesome thing is going to happen. We are going to write to the memory address in RCX our 0.55. You ready for this? I hope so. So, where is it? So RCX is 0.48, so 0.48, right? So it's 0. So next instruction we are going to write here. Keep an eye on that. Boom! You see, we wrote to the right value in memory, right? So if we keep running, we write the Z, nothing happened. So now we process the X, nothing happens. Now we process the next Y, right? So let's go down here. We are ready to write. So we want to write to E068. E068 is this one, right? Because that was the X, Y, Z, W, X, Y. So we should be writing exactly here. And let's run the instruction. Boom! That's exactly where we wrote, right? So now, if you let it run, boom, you see the 0 flag was set. So we jumped out and now we return, all right? So now we are back in Maya and you see that our plane moved up because we modified the position points and then in the Deformer we set them, right? So we saw step by step what was running in memory, so in RAM, into the register and how each instruction manipulated the register and brought back to memory, right? So I find this freaking fascinating. It's really nice to see what's happening there, right? So you really are in control of what you're doing, right? So it's really good to understand what's happening into the code, what your code is doing, okay? So for example, let's see that you're doing operation in Maya, multiplication of vector. Now that you have this knowledge, you can go into the disassembly and try to figure out what it's doing. And you should see that Maya is doing some extra operation, right, which are slower. And that's why, for example, manipulating the data using pointer in C++ in this kind of the same way we did in assembly. So the concept is the same, but in C++, so access the pointer and shifting the pointer and writing directly to the pointer, bypassing directly the Maya container is a massive optimization. You should get quite a nice boost out of it, right? So that's all thing we were able to understand and learn by learning assembly and write a Maya Deformer with it. So I hope by now you think I'm a little bit less crazy and actually start to think, okay, maybe it was worth it, right? Not worth it like, okay, I wrote a Deformer, let's put it in production. No, but it was worth it what we learned out of it, all right? So that's it for this video, guys. So next part, what I think we're going to do, we are going to optimize this code to use AVX, all right? So that's the next thing we're going to do in our assembly series. I hope you enjoy. Stay tuned, share the video, like it, the usual Jabba Jabba. See you around.